Assalamualaikum. My name is Nur Aimi Atira binti Muhammad Saleh, and today I would like to explain my answer from the assignment question in this video. Okay, so this is the first question. Suggest a process that can be done to improve the soil in terms of settlement at Site A, where Site A is a silty clay soil. Silty clay soil can be improved by using compaction and infill soil amendments such as organic matter and gypsum. Compaction can be done using roller or natural environment. The small size of clay particles means they fit closely together, leaving less room for air, water and nutrients to move, especially when pressure compacts them. The particle shape increases the likelihood of compaction. Clay particles are flat, like plates, instead of rounded, like grains of sand. Secondly, adding materials such as organic compost, pine bark, compost leaves, and gypsum to heavy clay can improve structure and help eliminate drainage and compaction problems. Okay, this is the second question. Suggest a process that can be done to improve the soil at Site B in terms of its bearing capacity. So there are two processes that can be done. So first is increasing depth of foundation. At the deeper depth, the overburden pressure on soil is higher. Hence, the soil is more compact at deeper depth. As a result, it shows higher bearing capacity. This method of improving bearing capacity of soil is not applicable if the subsoil materials grows wetter at the depth increases. This method has a limited use because with increase in depth, the weight and cost of foundation also increase. And the second process is draining the soil. With increase in percentage of water content in soil, the bearing capacity decrease. In case of sandy soil, the bearing capacity may reduce as much as 50% due to presence of water content. Cohesion-less soil such as sandy and gravelly soils can be drained by laying the porous pipes to a gentle slope over a bed of sand and filling the trench above the pipes with loose boulders. This trench should lead to the nearest soil for any water body. Okay, so this is the question number 3. So for the quick test for silty clay, I suggest is a unconfined compression test. The unconfined compression test is a special form of triaxial test in which the confining pressure is zero. The test can be conducted only on clay soils which can stand without confinement. There are two types of UCC machines, with a spring and a machine with a proving things. A compressive force is applied to the specimen till failure. The compressive load can be measured using proving ring. Second for the silty sand, which is Site B. A soil specimen of size 60 by 60 by 25 mm is taken. It is placed in the direct shear box and compacted. The upper grade plate, porous stone and pressure pad is placed on the specimen. Normal load and shear load is applied till failure. So for the silty clay, which is Site A, just now I said it have a unconfided compression test and consolidated soil. It is a undrained soil. And for silty clay, is a direct shear test, unconsolidated and drained soil. Okay, next is the question number 4. Question number 4 is briefly explain the procedure of the standard compaction test and provide an example of calculation and result. So this is a step for the doing standard compaction test. So for first is take sufficient quantity of representative soil. Second is take about 3 kg of soil and add water to bring its water content to about 5% below the estimate optimum moisture content. Next, we clean the mold, measure its diameter of head and weigh it without the collar. Number 4 is feed the collar and compact the moist soil in 3 equal layers by the rammer with evenly distributed blows to each layer. Use 25 blows for 4 inches diameter and 56 blows for 6 inches diameter mold to the total height of mold of the with collar. Okay, next is remove the collar, trim the compacted soil even with the top of the mold with a straight steel edge. Number 6, remove all the soil from the mold, split it and take about 100 grams sample of water content determination. Number 7, break the soil lumps, mix it with remaining soil in the tray. Add more water to increase the water content by 2 to 3%. Number 8, calculate water content for each trail and corresponding dry density. Number 9, plot the compaction curve between water content as a coordinate. And the last one is note the water content against the peak of the curve as optimum moisture content and the corresponding dry density as maximum dry density. Okay, so this is the calculation, an example of the calculation, and this is a result for standard. This is a example result for this experiment, which is standard Proctor test, standard compaction test. Okay, I think that's all from me. Thank you for listening, sir. Assalamualaikum.